All types of organic reactions can be categorized into four: addition, elimination, substitution, and rearrangement. Addition reaction can be divided into two types: electrophilic addition, nucleophilic addition, while substitution can be grouped into three types: electrophilic substitution, nucleophilic substitution, and free radical. Before you get into general types of reaction, you have to know the meaning of nucleophile and electrophile. Nucleophile is electron-rich species. It can be neutral or negatively charged, while electrophile is electron-deficient species. It can be neutral or positively charged. The definition of chemical reactions is reactions in which a nucleophile reacts with an electrophile. Remember that the electron-deficient species is electrophile, so our carbon is electrophilic carbon, while this is negatively charged, so it is an nucleophile. In addition reaction, a reaction in which atom or group of atoms add to a molecule with multiple bonds. For double or triple bond, keep in mind that addition reaction involve molecule with multiple bond. It doesn't matter whether it is alkene, alkyne, or even ketone or propanol. Ketone and propanol have C double bond O. Addition reaction involve breaking of one pi bond to form two sigma bond. So here we have alkene, one sigma bond, one pi bond, and react with Br. So our alkene is rich in electron-rich species. So it is nucleophile. So the nucleophile will break the pi bond and form two sigma bond with Br. Note that this carbon has two hydrogen. This carbon has two hydrogen in the reactant. So look at the product. Make sure that the number of hydrogen attached to each carbon is the same as the reactant, but addition of new atom. That's why we call it addition reaction. All parts of the adding reagent appear in the product. Electrophilic addition. Remember that we have two types of addition: electrophilic addition and nucleophilic addition. For electrophilic addition, involve typical reaction for alkene or alkyne. So our C double bond C and C triple bond C in alkyne, they are both nucleophiles, electron-rich species. Susceptible to attack electrophile, the name of this reaction is electrophilic addition because they are nucleophile and electrophile will add into this reaction. So that's why the reaction is called electrophilic addition. This is the same example as I've shown you before. So now, look at the second reaction. We have an alkene react with HCl. Our nucleophile is alkene and electrophile is electron deficient. So our H is electrophile. So alkene will attack electrophile and the carbon will get hydrogen. Note that the left side of the carbon has two hydrogen, and at the product, the left side of carbon has two hydrogen initially, and new hydrogen is added into this carbon, and another carbon will receive Cl. Note that this carbon has two hydrogen as the same as before. For nucleophilic addition, most common reaction of aldehydes and ketones. Remember that addition involves multiple bonds. So now your multiple bond is C double bond O for aldehydes and ketones. Nucleophile approach to the electrophilic C of carbonyl group. So this reaction is called nucleophilic addition because your electrophile is C. It is called nucleophilic because you add nucleophile into the electrophile. So that's why it is called nucleophilic addition. Initiated by nucleophile, typical reaction for unsaturated compounds with electrophilic sites. So our electrophile is C, electron deficient species. We have H- as a nucleophile. It will attack C as electrophile because C here is electron deficient species, O here is electron rich species, so our nucleophile will attack the electrophilic site and it will form alcohol. This carbon atom, note that it has two R groups and in the product it will have two R group as well. So in the reactant we have one oxygen, in the product we have one more oxygen. The addition is two more hydrogen. So that's why we call it addition reaction, and we add nucleophile into the reaction, so we call it as nucleophilic addition. Substitution reaction. A reaction in which an atom or a group of atoms in a molecule is replaced by another atom or group of atoms from the reagent. So it's about replacement of atoms. Two reactants exchange parts to give new products. The characteristic of reaction of saturated and aromatic compounds. The example shown here is saturated compound. So we have alkene react with Cl2 in the presence of light. So this hydrogen is substituted by one chlorine atom. So it is called substitution reaction. And you'll get the byproduct of HCl. Electrophilic aromatic substitution. Remember, we have three types of substitution: electrophilic substitution, nucleophilic substitution, and free radical. For electrophilic aromatic substitution, the characteristic of all aromatic compounds: aromatic nucleus stable with high electron density. So our aromatic ring is the nucleophile because benzene has 6 pi electrons, so it is electron-rich species. It is susceptible to attack electrophile because the aromatic ring itself is nucleophile, so it will attack electrophile. For example, we have benzene ring will attack Br, so substitution. So we actually have here one hydrogen here substituted by one atom of Br. So the hydrogen will combine with another Br as byproduct. The second type of substitution, nucleophilic substitution, occur in saturated compounds with polar bonds as functional group. Most common reaction of alkyl halides and alcohol. So our alkyl halides and alcohols are electrophile because they both have electron deficient species at R site, and the nucleophile will attack the electrophile species. Our nucleophile in this example is OH- and carbon site is electrophilic carbon. So this substitution is called nucleophilic substitution because the nucleophile will substitute I. So it will get alcohol and the byproduct is I-, the anion. The third type is free radical substitution, most common reaction of alkanes. We all know that alkane has no functional group. Alkane is unreactive. So, for alkane to react, it will need the help of light. Substitution, which involves free radical as intermediate species. You'll get into details of this substitution reaction in chapter 2. So, the hydrogen in alkane is substituted by Br and you'll get HBr as byproduct. Another example, the alkane, this H is substituted by one atom of Cl and HCl as byproduct. Note that in free radical substitution, you are required UV light to get to be a free radical substitution. This is the summary of types of organic reactions. Electrophilic addition involve alkenes, alkynes. Electrophilic aromatic substitution involve aromatic compounds. Nucleophilic addition involves aldehydes and ketones. Nucleophilic substitution involve alkyl halides, alcohols, derivatives of carboxylic acid. Finally, free radical substitution involves alkanes. Elimination reaction. This reaction is opposite of addition reaction. A single reactant splits into two products. This is the method for preparing compounds with double and triple bond. So, for example, here you have alkyl halide react with base and it will produce alkene. In this reaction, you eliminate H and Br. So, the carbon atom involved in elimination of H and Br will form double bond. And the byproduct is HBr. In this elimination reaction, you remove atoms or group of atoms from adjacent carbon atoms. So this is adjacent carbon atoms of a molecule to form a multiple bond for double or triple bond. In this example, we form double bond. The last type of reaction, rearrangement reaction. In rearrangement reaction, a reaction in which atoms or group of atoms in a molecule change position. No addition, no substitution, no elimination. Just atoms or group of atoms change their position. This reaction occurs when a single reactant reorganizes the bonds and atoms. So, for example, 1-butene, let's focus on the carbon here. This carbon has 1 hydrogen and 2 carbons with 5 hydrogen. This carbon has 1 hydrogen and another 1 hydrogen. So, in the presence of acid catalyst, this carbon only left with 1 carbon. Initially, it has 2 carbon. And this carbon has 1 carbon and 1 hydrogen. Initially, this carbon has 2 hydrogen. This reaction is rearrangement reaction because if you count the number of atoms in total in the reaction and the products are the same. So you have 1, 2, 3, 4 carbon and 1, 2, 3, 4 carbon, and hydrogen you have 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. Same number of atoms in the reactant and products, but they only change their position. This is rearrangement reaction. Next, rearrangement reaction also occur in reactions involving the formation of a carbocation intermediate. Okay, let's have a look at this hydrogen. Initially, this hydrogen and this carbon, we call it carbon cation, carbocation. So 1 to hydrogen shift, this hydrogen shift from 1 to 2. So here, this hydrogen 2, 1 to hydrogen shift, and the carbocation shift here. So this is the rearrangement reaction. And this one, 1 to methyl shift, you have 1 methyl here, and the methyl shift to here. So this is another example for rearrangement reaction.